Good morning, dear students. Today we will discuss hypothesis testing. In our last presentation, we left the presentation like that. We'll be discussing univariate analysis, univariate statistics basically. But for that, we need to know what hypothesis testing is. That is why we'll be studying hypothesis testing in this presentation. Then we'll go with univariate statistics. Let us see what are the things required to know before starting with univariate statistics or any kind of analysis. Test of statistical significance and hypothesis testing one variable at a time. Hypothesis testing one variable at a time is with univariate statistics, but for any kind of analysis rather than after descriptive analysis, you must know these two things. What is test of statistical significance and hypothesis testing? So we'll start with these two things in this presentation. What do you mean by a hypothesis? It is basically an unproven proposition, or you can say it is an unproven supposition that tentatively explains certain facts or phenomena and assumption about the nature of the world. And it would contain, we would never state single hypothesis. We would always state hypothesis in pair, and that would be like one would be null hypothesis and another one would be alternate hypothesis. These are opposite of each other. Null means zero, null means no relationship, no difference and all. And alternative hypothesis would state, either it would state that there is a difference between the variables, or it would state there is a positive relationship of these two things, there is a negative relationship, or there is a relationship at least, right? This would be stated like that. It would be a kind of opposite statement than that of null hypothesis. And hypotheses are, for example, you might say corporate social responsibility of any firm directly affect profitability of the firm. That can also happen, right? And if you would be stating this as hypothesis, you will be creating two hypotheses. One would state CSR does not affect, or CSR has no effect on profitability of the firm, and then that would be your null hypothesis. And when you say that CSR affects profitability of the firm, that would be your alternative hypothesis. Either you can state this in three ways. The alternate hypothesis, null hypothesis is simple: CSR does not affect profitability of the firm, that's it. But when it comes to alternate hypothesis, you can have hypothesis like this: CSR affects profitability of the firm, or CSR, corporate social responsibility, CSR affects profitability of the firm in a positive way, or CSR affects profitability of the firm in a negative way. Three options are there. As per your review of literature, you can state either of them, right? Hypothesis basically is an assumption, like we just had a look at, unproven proposition, supposition. These are basically assumptions about the population parameter to be tested based on sample information. This is a kind of assumption you will be taking as per your population. For example, I want to study top 500 companies in India. That means top 500 companies are the population for my study, and after removing the companies from 500 which are not up to the mark for the analysis, or maybe for example, if I want to study those 500 companies for 10 years, companies, today we are in 2021. When we talk about 2021, and that means you will be collecting data till 2020 or till 2021. So that means companies which started their business after 2011, they would not be counted in the sample, right? So this way you will be reducing a few companies. Few companies might not have shared their data, or few companies might be like they were not available in 2-3 years, and due to lockdown also so many things have happened. So there might be so many parameters due to which you might remove a few companies from that particular population, and then you'll start with your further analysis, right? So when you say that you are assuming something about the population, that is basically hypothesis. It is made about the value of some parameter, those provided by the sample. you will be stating, for example, we just mentioned, for example, whether CSR of a company is affecting the profitability of the company or not, or whether advertising is affecting the sales of the company or not, right? This way you can state the hypothesis. If sample static differ from the hypothesis, if the result you will be getting is different from the hypothesis, it would be rejected. That is why we call it as test of hypothesis. Either of them would be rejected for sure, null or alternate, because these are opposite. Just in case you sometimes get the, get questions like define null hypothesis. This is statement about the status quo of no difference. Whenever you are stating null hypothesis, null means zero, no difference, no relationship. You just have to remember this. When we have got two hypotheses, null means zero, no difference. You can say null means null, nothing, right? So you would be, you can remember this with the help of this. Null means no, null means zero, nothing is there, right? So we'll be stating it like no difference, no relationship. But when it comes to alternate hypothesis statement, that indicates the opposite of null hypothesis. That means it would state some relationship, either positive or negative, or just it would be a statement like it affects the other thing, right? For example, advertisement budget would affect the sales of the company, like this. For example, null hypothesis that the mean is equal to 3.0, right? And you would be stating null hypothesis like this: h naught, h and 0 in the leg of h, like mu is equal to 3.0. This is your null hypothesis, and this would be your alternate hypothesis, that the mean does not equal to 3.0. And alternate hypotheses are always stated like this: h1, h2, h3, h4, h5. For example, in your study, you might be having 5 hypotheses, right? Then your null hypothesis would always be like this: h0, h0 then h1, h0 then h2, h0 then h3, h0 then h4, h0 and h5. Or in case you feel like that you might not recognize them properly if they are always stated in h0, then you can do one thing: h01 can be put here, but it would always be in the form of h0, and alternate would always be in the form of h1, h2, h3, and counting continues. Yes, this is also very important: significance level. Critical probability in choosing between the null hypothesis and the alternative hypothesis. After the analysis, you'll be get some figures, you'll have a few things in your hand. Now you need to check whether the test was significant or not. Confidence level, alpha, probability level selected is typically 0.5 or 0.01, and too low to warrant support for the null hypothesis. Significance level basically is a kind of confidence level chosen for the study. Confidence level is like I mentioned, 0.05 and 0.01 is taken for the most of the studies. Sometimes in social sciences we go for 0.10 as well. 0.05 here, you can see that it indicates 5%. That means probability level selected is typically 0.05, can be said like this, that you are sort of following 5% errors in the analysis. Confidence interval means you are 95% confident that your analysis is correct and 5% errors might be there, because in anything you do in your life, there that cannot be, you cannot expect things to be 100% error free, and this is just analysis, and you will not be taking 100% population. You will be selecting a sample for the study for from the whole population. Then errors can be there, right? So that is why we assume a significant level confidence interval for our study, and that has to be assumed before you start analysis, so that we don't get confused later on that whether to choose 0.05 or 0.01. But in studies, in some studies which are just for the purpose of checking at initial level, you can allow 0.10 as well, 10% interval. That means 90% confidence interval and 10% errors. So that this is just allowed when you are going to study further, or this is just for the purpose of a project. That's it. Otherwise, in medical sciences, we are very clear. We take very high level of precision, but in case of management, in case of social sciences, we'll allow some errors, right? Procedure of hypothesis testing. Number one, you will be setting up a hypothesis. In this hypothesis is established, which needs to be tested. Generally, two different hypotheses are established instead of one, which are normally referred as null hypothesis and alternate hypothesis, like we just mentioned in the last slides. And you can say that here you have mentioned two hypotheses. Null hypothesis, that mean is equal to 3, and alternate hypothesis, mean is not 3, right? Second step is set up a suitable significance level. The level of significance is generally specified before any samples are drawn, so that results obtained will not influence our choice. Like I just mentioned in the last slide, normally 5% or 1% level is considered, right? That's it. We have discussed these two in detail. Now, next is determination of suitable test statistic. How would you check the suitable test statistic for your analysis? It would depend on so many things. For example, if you want to test difference between the variables, then you can go with either t-test or ANOVA. If you want to check the relationship between variables, you can go with correlation regression. This depends on the kind of objective you have, kind of hypothesis you have set, right? On that basis, you will be determining a suitable test statistic. Whatever the test is, significant level you have chosen would remain the same. Then determine the critical region. The region represented by those values of the test statistic that would lead to rejection of null hypothesis is critical region. This is very much related with your significance level. Your significance level is dependent on critical region. Basically, when you are doing the test, by yourself, or you can say when you are not using the software for doing the test, you are doing it by yourself, you're doing calculations by your own, then you will be getting a critical region. And with the help of this critical region, you will be able to get the significance level value. So this is very much related to your significance level, confidence interval. Then doing computations. Once you have determined the critical region, you will be doing all the computations as per the test. For example, you have to go with t-test. You will be applying the formulation, and you'll get the result, and accordingly you will decide whether it is right or not. In the last, you will be making decisions on the basis of results you have got. For example, significance level, you might have mentioned 0.05, but significance level here is not 0.05. It is above that. For example, you get p-value as p-value is basically we denote significance level with the help of p-value. And for example, if your p-value comes out to be 0.06, then you will be rejecting the null hypothesis, your alternative hypothesis. You will be stating that you will not be able to accept that, right? But if your value is below 0.05, that means test is significant. If your test comes out to be significant, that means you are going to reject null hypothesis and will be moving towards acceptance of alternate hypothesis. This way you will be making decisions as per the test. This is the first thing we'll be looking for, which is significance level. Then only we'll be checking other other results we have got, other values we have got, whether they are related or not, whether there's a difference or not. We'll be checking these things later. First we'll be checking, first step after the analysis is checking the p-value, that is significance level. Possible results when hypothesis is tested. There are 4 possible results. One is hypothesis is true, but our test rejects it somehow, or hypothesis is false, but our test accepts it. Both of them are wrong conditions, right? If hypothesis is true and our test accepted, that's okay. If hypothesis is false, then our test rejected, that's also okay. Let us discuss them with the help of type 1 and type 2 error. These are the errors in the analysis, right? When our hypothesis is true but we reject it, or if it is false and we accept it, both are wrong conditions. These create errors in the analysis, and these are type 1 and type 2 errors. Basically, when your null hypothesis is true and you accept the null, that means you are doing the right thing. And same here, when null is false and you reject it, right? But the thing is, when your null hypothesis is true but still you reject it, then it would be type 1 error. And when your null hypothesis is false but you accept it, so we define these errors as type 1 and type 2 errors, and we can state them with the help of alpha and beta errors. We can reduce some levels of error with the help of some analysis, some precautions and all, but not all of them. That is why we have taken level of significance, confidence interval. Over there also we are trying to justify some portion of error, or we can say we are trying to neglect some portion of error. Let us see the whole procedure with the help of this example. Like I already stated, null hypothesis that the mean is equal to 3, and alternate is the mean is not equal to 3. This is how your sample would be distributed. For example, you have stated the whole sample on a chart like this, x-axis and y-axis, and this would fall like this, right? And here mean is 3. These are your critical regions, like this. Here alpha value is 0.025 and 0.025. Now you can say this is your lower limit and this is your upper limit, which are to be taken care of. You'll be calculating critical values, upper limit as well as lower limit with the help of this formula, like this. Here you got the upper limit 3.196 by applying the formula for upper limit, and then you can apply the formula for lower limit and get the answers for lower limit as well, 2.804. And you will be mentioning them here, like this is your lower limit and this is your upper limit for the analysis, and this is the X bar from the sample. There is one more way to calculate, Z observations, and this is your X bar from the sample, and this is your mean, and this is SX bar. We have already discussed it in our last presentations at the time of discussion of population and sample deciding. Alternate way of testing the hypothesis is X bar minus mean divided by SX bar, sample X bar, sample of X bar, right? After applying the formula, you'll get your limits here, and you can divide this particular Z observation in lower and upper limit now. Yes, there is one more thing when we discuss hypothesis testing for univariate test statistic. There can be two kind of test. One is two-tailed test, another one is one-tailed. Two-tailed test is okay because you are considering both the tails in the analysis, right? You will be having upper limit and lower limit both. You will be having two critical regions. But when it comes to one-tailed test, it can be like whether it is right-tailed test or it is left-tailed test, right? So there are two, right-tailed and left-tailed. Let us discuss them. How would you go with these two kind of the test, especially in case of univariate? Like this. Sign in the tails of a test. How would you do it? For example, if it is a two-tailed test, there would always be either equal to or not equal to. Equal to for null hypothesis, like we have mentioned in the example, and not equal to for alternate hypothesis, right? And rejection region would be in the both tails. Both side you will be having rejection regions. And when it comes to left-tailed test, that means In null hypothesis, you will be stating there is no difference, nothing like that. That means it would be opposite of left tail. So it would be greater than, right? At left, it would be a greater area, greater than or equal to. But when it comes to alternate hypothesis, it is always less than, because at left, it should be left when we are talking about left tail test. And region would be decided in the case of left tail, right? Where alternate hypothesis lies. And in case of right tail test, again, it would be the opposite. Right tail means less than equal to sign would be there in null hypothesis, and greater than would be in alternate hypothesis. And when we say that alternate is greater than, that means it would be in the your rejection region would be decided in the right tail. This is right tail test. When you are saying that right tail, that means rejection region is also in the right tail. This way you will be able to analyze whether you are going for two tail or one tail test, and for one tail also whether it is a right tail or left tail test. Now, last is test concerning large samples, population mean, difference between two means. How would you go about them? If you have large samples, accordingly, you will be able to decide whether you will be going for T test or Z test, right? There are things. We'll be discussing these things again whenever we'll be doing any kind of the analysis. We'll be performing analysis from next presentation. Then we'll see whether in case of what should you do in case of small samples and large samples. There are different tests for both of them. If you are going with population mean, what kind of the test you are going to do, then difference between two means, what kind of the test we have available, and from among them also which one you will be choosing, that is also a thing. Then attributes, as per the attributes, what are the tests available, then population proportion and difference between two proportions, right? These are the tests we'll be discussing. These are the parameters, you can say, we'll be discussing, as due to which on the basis of which we'll be deciding our test in the all upcoming slides presentations. That's it. Let us discuss some true false. Number one, monovariate statistical analysis test, hypothesis involving only one variable. Is it? Have we ever heard monovariate statistical analysis? No, it's univariate statistical analysis when it comes to one variable. So it is false. There is no word like monovariate. Sometimes words confuse us like this. Mono seems like, yes, it is talking about one variable, but it is not. Second is, the researcher's hypothesis is generally stated in the form of a null hypothesis. Is it? No, researcher's hypothesis is always stated in the form of alternative hypothesis. Null hypothesis would always state no difference, no relationship. Right? When we are trying to prove some relationship, we are trying to check some difference, then of course we'll be stating that in the form of alternate hypothesis. So it is again false. Third is, a significance level is a critical probability associated with a statistical hypothesis test that indicates how likely it is that an inference supporting a difference between an observed value and some statistical expectation is true. Yes, this is true. Significance level basically is checked this way. So we have just discussed in our last slides. So, true. Fourth is, the term p-value stands for power value. Is it? P-value, whenever we talk about statistics, would always stands for probability value. And this is used for your significance value as well, because there we say that probability of having errors is this, right? So that is why we call that significance level as p-value. It is false. Fifth is, in hypothesis testing, the symbol typically used to specify the significance level of the test is B. Is it? It's false. Significance is, test is basically alpha. Then sixth is, in hypothesis testing, the value of T that lie on the boundary of the region of rejection are called the critical values. Yes, These lines at the region of rejection are basically called as critical values, as we have discussed in the example. Last is the researcher using sampling runs the risk of committing two types of errors. Yes, one is primary errors and second is secondary errors. Is it? Yes, the researcher using sample runs the risk of committing two types of error. That is 100% true. But these two errors are type 1 and type 2 errors, not the primary and secondary errors. So it is false. Let us discuss some questions for this particular unit. Self-assessment questions are: what is hypothesis? Compare null and alternate hypothesis. How would you compare them? You will be stating the definition of hypothesis, then you will be stating what null hypothesis is, like it is for no difference, and what alternate hypothesis is, and if possible you will be giving one example. For example, anything from your business organization, any related thing you feel like. For example, if you are in marketing, you can state some example from marketing. If you are in finance, you can state some example from finance, right? As per your area, you will be stating one example each. Like we discussed the example of CSR, whether corporate social responsibility affects profitability of the firm or not. In that case, what kind of the hypothesis you would be having? Like null hypothesis would be CSR does not affect profitability of the firm. That's it. There is no relationship between CSR and profitability of the firm. That is your null hypothesis. And alternate hypothesis can be like CSR affects profitability of the firm in a positive way or in a negative way, or at least it just affects. These three possibilities are there as per the review of literature. Then second is list the procedure of hypothesis testing. Explain all the steps with example. We have discussed the procedure, right? You'll be listing down all the steps and you'll be explaining them one by one with the help of examples. You do not have to discuss example numerically, but at least you will be stating examples like this can be this and all that. Like for example of null and alternate hypothesis, then significance level, what kind of the significance level in what kind of the studies we use. This way you will be stating example. Third is compare and contrast type 1 errors and type 2 errors and explain which one is of more concern to researchers. Type 1 and type 2 errors we have already discussed. It comes after the analysis, like whether the analysis had been done rightly or not, right? So after the test, you can just mention like these two errors comes in, and you can even draw that particular diagram we have mentioned in the presentation. That's it. Thank you. In our next presentation, we will start with univariate analysis, univariate statistics. We have just discussed hypothesis testing, what is significance level, what is a critical region, everything which is to be done before univariate statistics has been done in this particular presentation. We'll be starting univariate statistics, univariate test in our next presentation. Thank you.